In this video, we will begin Chapter 5, Expressions. So what we're going to do is we're going to be starting kind of cracking the surface of algebra. And we'll begin by looking at algebraic expressions. So the first thing we need to learn is, how do I write algebraic expressions? So we need to go over some key vocabulary, and this vocabulary is going to be very important because it's going to be the words that we use in class constantly. So we got to get this stuff memorized and really understand the difference between them so that when we're talking about this stuff, we're on the same page. One of the first things we'll look at is an algebraic expression. And this is one of these five, this is probably the least important, but it's important as far as just getting a definition so we know what we're talking about. So an algebraic expression has variables, numbers, and operations. We'll define variables soon. Numbers are numbers, 2, 4, -10, -3/4. Operations are when we're talking about addition, subtraction, multiplication, division. So operations is that idea of addition, subtraction, multiplication, and division. Now a variable is the part of the expression that can vary. And what I mean by vary is that it can change. So say I'm looking at this 4y minus 9. 4 is not going to change. 9 is not going to change. But the y is the thing that changes. I could say y equals 3, and we plug 3 in. Or I could say y equals 7, and we plug 7 in. So the variable is going to be a letter. Let me change colors. Is a letter representing a number. So when I'm looking at 4y minus 9, which part is the letter representing a number? The y. Now there's a coefficient. The coefficient is the number that is being multiplied with the variable. You can also think of it as just the number right next to the variable. So we'll call the coefficient the number in front of the variable. It's in front of the variable. So when I look at 4y minus 9, which number is in front of the variable? Well, here's our variable, and here's the number in front of it. So 4. Is our coefficient. Now a constant is a number that's all by itself. So the 4 is kind of attached to the y, and then we have this minus 9. So the constant is a number by itself. There's no variable attached to it, and it's just kind of hanging out there by itself. Now what I want to point out is for us to talk about this constant, we have to use our keep, change idea. So we'll keep this first term the same, and then we change. So we're going to change to a plus the minus. So now my constant is really -9 in this case. So by doing the keep, change, change, we can see what the constant really is. And our last definition will be like terms. And like terms are terms with the same variable and, this is important, and the same exponent. So let's look at how we can think of like terms. So if I had 4x negative 7x squared 3x squared and 8x, which ones are the same? Well, they need to have the same variable and the same exponent. So this term, the 4x, is the same as 8x. And the 3x squared is the same as negative 7x squared. So these are like terms because they have the same variable and they don't have an exponent. And these are like terms, 3x squared and negative 6x squared, because they have the same variable x, but they have the exponent of 2. So even though we have the same variable x, we also need the same exponent. No exponent, exponent of 2. So these are not like terms. Next, we're going to list some words that we'll be seeing as far as how we can translate them into mathematical operations. So I'm just going to list these pretty fast, and then you can pause to catch up. So we'll start with addition. Addition is sum, all together, total, increase, in all, more than. All of these words, when we see them, imply that we will usually be adding, we will usually have an addition sign in this kind of problem. For subtraction, we have difference, borrow, leftover, decrease, take away, and less than. For multiplication, we'll see the word product, times, of, in all. Notice how in all could be multiplication or addition, so make sure it's not always going to be addition or always be multiplication. It depends on the problem. And the same with the word altogether. Both of these can be addition or multiplication. And in division, we have quotient, split, each, equal shares, into, and evenly. So if we're splitting something evenly, that means we'll be dividing. So if you want, go ahead and pause right here. That way you can get this whole list down, and then we'll move forward. Okay, so hopefully you paused and got this whole list written down. There's one important thing I need to add to this, and that's this idea of more than and less than. So both of these have they're special in the sense that when we see them, we have to flip the order of the numbers. And as we move through these examples that we're about to do, when we get to one that uses more than or less than, this idea of flipping the order of the numbers will make more sense. Okay, so let's look at some examples. The sum of 8 and a number. Well, the sum of 8 and a number will be 8. And here's the new part. If we have a number, if we don't know the number, what can we use to represent a number? Well, if we look up here, when we're trying to represent a number, we can use a letter. So we'll use a variable to represent a number. So for our first variable, we'll use x. We can use any letter, but I'm just choosing x. X is kind of like the most common. On our next one, we'll use the difference. So the difference of 24 minus, and we have a number again. So let's use a different variable, so we'll use y. Next, we'll do the product of 5 and a number. So product is multiplication. So we'll do 5 times a number, w. But also, this is something that we definitely need to get memorized. We can say 5 times w where you see it, or we could say 5w. And this is what you'll see most common. So when you see a coefficient next to a variable, coefficient, the 5, next to a variable, the letter w, this is multiplication. 5 times w. Okay, next we have the quotient of 35 and a number. So 35 divided by a number, let's use t. 35 divided by t. Then we'll have 2/3 of, there's our word, 2/3 of a number. And so when we see of just by itself, we know that that's going to be multiplication. So we can say 2/3. And we're gonna stop using this dot so much because we want to be efficient and write less. So it's gonna be 2/3, and then let's use p. So we have 2/3 of nothing written, so it's implied multiplication. A number will be our variable p. Okay, let's flip to the back side. So now we have a number increased by 15. So a number is coming first. So we'll say x plus increased by 15. Our next one says 4 divided by a number plus 3. So we'll have 4 divided by a number. Let's use y. And then we have plus 3. Okay, here comes a less than. So this one is where it gets tricky. So if we look back at our front page, less than, that's that extra note I made right here. When it's less than, we will flip the order of the numbers. So if it's 17 less than the square of a number, I need to flip the order of how this comes. So normally, like in the previous one, we did 4 came first, divided by, we had divided, a number came next, and then plus 3. When it's a less than or more than, I need to flip this order. So since the square of a number is coming second, I need to write that first, only because it's less than. So we'll say the square of a number, so that's a number, and then it's squared, and then it's less than, that's minus 17. So notice how when it was less than, we switched this order. These two kind of switched places when we wrote it. The second part came first, and that first number came second. Next we'll have 8 times a number. So we want to do 8 times a number. Remember, we're not going to write times anymore, so I'm just going to say 8r, which is the same as 8 times r. Oop, we got another less than. So 6 less than a number. What are we going to do when it's a less than? We're going to switch the order. Switch the order. So I'm going to switch this order right here. Switching places. So if twice a number is second, I will use my twice a number, twice being 2 times. So let's go to S, and then less than is our minus, and then 6. So even though 6 came first, because it's less than, I'm switching that order, and the minus 6 came second. So at this point, I'd like you to pause and see if you can try 1 through 4 with actual, like in word problem situations. Write an expression for each of these. So pause right here and write an expression for 1 through 4. So I hope you took the time to try this. So we have savings of $25. So we have 25 plus, if I'm getting $10 each week, we could say $10 times W. Because we started off with $25 and then we're adding $10 for each week. 8 feet less than the height, so we have a less than, so it means we're going to switch our order. So we'll start with the height minus 8. Kumar has twice the number of goals as Jacob. So we can say Kumar has twice the number of goals as Jacob. So we'll say that 2, if he has twice the number, we'll just say 2G for a G for goals. So for the total cost of bowling, where G is the number of games played and 2 represents the cost of shoes, we can say the number of games played times the cost of each game plus 2 for the shoes. So here on 1 through 4, what I want to do is we'll just evaluate each expression, and what we're doing is we're plugging our value for our variable in to our equation, and now we're just dealing with these negatives now. So the negatives are not going away. So let me show you an example. We'll plug it in. 2 times negative 4 plus 3. And we just use our negative rules. Different sign, subtract. So I have 1, keep the sign. I have more negatives, so I'll keep that negative 1. And then we'll bring down that 2. Remember, anytime we don't see something, we're going to assume it's multiplication. So 2 times negative 1 would be positive times a negative is negative 2. So please, if you would, right now, go ahead and pause right here and try out the rest of them on your own. Okay, so I hope you took the time to try these. Let's look at them. We have 4 times We have that hidden multiplication right there, and then we have a negative 3. We'll put that negative 3 in parentheses and raise it to the third power. So we end up with 4 times negative 3 times negative 3 times negative 3. We'll just do it 2 numbers at a time. Positive times a negative is a negative, negative 12 times negative 3 times negative 3. And then we'll do a negative times a negative is positive, and 12 times 3 is 36. Bring down that last times negative 3, and we'll get positive times a negative is negative, and 3 times 36 is 108. And then we're done. On this next one, we'll plug in our numbers. We have 3 times 8 plus negative 5, and we'll raise that to the second power. We'll do our parentheses first. 8 plus negative 5 would be 3, so we have 3 times 3 to the second power. We'll write this out, so it's 3 times 3 times 3. 3 to the second power is these last two 3's. I'm going to do this one just left to right. 3 times 3 is 9. 9 times 3 is 27. One more problem, then we're done. So we'll have 5 plus negative 1 to that second power divided by a negative, coming from right here in front of that 2, is equal to, well, we'll have 5 plus, this would be negative 1 to the second power, exponents coming first, so we have negative 1 times negative 1, so that'd be a positive 1, so there's our positive 1, divided by negative 2. We have to do our addition on top first before we do this division, because remember that fraction bar kind of separates it into 2 separate problems. So we'll get 6 divided by negative 2. Positive divided by negative is a negative, and 6 divided by 2 is 3. So thank you for watching this video, and that is our notes for algebraic expressions.